We're looking at Unit 7, Part 1, and our objectives for this unit are to solve for missing sides in special right triangles, to analyze similar shapes and to use SOHCAHTOA, solve for all 6 trig ratios, and to solve for all 6 trig ratios when given a coordinate point. When solving for special right triangles, there's 2 different triangles you're going to encounter, a 60-30-90 and a 45-45-90. When finding the hypotenuse in a 60-30-90, you're going to do the short leg times 2, as seen in the picture, and when you're finding the long leg, it's going to be a short leg times square root of 3, as seen in the picture, because there's short leg. I know it's not very good drawing, but that's short leg, this is long leg, short leg times square root of 3, it's right there. In a 45-45-90, when you're finding the hypotenuse, it's going to be the leg, since these two are congruent, it's going to be the leg times square root of 2. So that's how we find the hypotenuse, and then obviously, like I said, these two are the exact same because it's a 45-degree angle on either side of it. For an example of a 60-30-90, it gives us 8 as the hypotenuse, x is the short side, and y is the long side. So when we're finding x, we know that 2 times the short side equals the hypotenuse. So 2x equals 8 equals 4. So that we know that the short side is 4. When finding y, we know that it's going to be the short side times square root of 3. So 4 times square root of 3 to give us y. For example 2, with the 45-45-90, we know that one of the sides that are congruent times square root of 2 is going to give us the hypotenuse. So in this case, one of the sides is actually the square root of 2. So it's going to be square root of 2 times square root of 2, which is going to give us 2. And then obviously, since these two are the exact same, it's going to be the square root of 2 as x as well. And just a recap for SOHCAHTOA, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. For an example of this, to find sine of 45, we're going to go opposite and then hypotenuse, x over 15. And then when you put that in the calculator, it's 10.61. When you're finding cosine of 60, it's going to be adjacent over hypotenuse, 10 over x, and then when you put that in the calculator, you get 20. And then, when you're finding tangent of x, we can see that it's going to be opposite over adjacent, which is going to give us 3. So when you put that in the calculator, it's going to give you 71.57 as the angle measure. When analyzing similar shapes, we know that there's 3 different ways to do it. There's SAS, SSS, and angle-angle, which is AA. SSS is side-side-side, and SAS is side-angle-side. And in these 2 examples, we're going to have to determine if it's SAS, SSS, or AA, and if it is congruent or not. So when we're trying to figure this out, we're going to do the corresponding sides divided by each other to see if they all equal the same amount, to figure out whether it's going to be congruent or not. So 80 divided by 5 equals 16, 119 divided by 7 equals 17, and 160 divided by 10 equals 16. So we know that these two are not similar. This isn't supposed to be congruent, it's supposed to be similar. So these two are not similar because their sides are not corresponding. And for that example, it was side, side, side. In that example, side, 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 because it gave you all 3 side measurements. In this example, we know it's going to be SAS because it gives you angle measures. So SAS. And then to figure out the corresponding sides, you're going to do each side divided by each. So 50 divided by 10 is 5. 37.5 divided by 7.5 equals 5. So we know, and then we also know that these 2 angles are corresponding because they're the exact same angles. So we know that these 2 are similar, not congruent, but they're similar, ABC to DEF. When finding the scale factor, surface area, and volume ratios, we know that it's A to B for scale factor. For surface area, it's A squared to B squared. And volume, it's A cubed to B cubed. When we're finding this, in this example, we need to find the larger, because these two are, it's smaller to larger, and so this one's the smaller shapes. So we need to find the larger shapes corresponding to this one. So for the surface area, we're going to be doing 2 we need to figure out what it is for this one. So you're going to do 2 to the second power to equal 4, and 68 divided by 4 to give you 17. When you get 17, you know what to do times the square root, or the 5 to the second. So it's going to be 17 times 25. And then that's going to tell you what the surface area is for the larger shape, which is 425 units squared. When you're finding the volume, you're going to do the same type of thing. You're going to do 2 cubed, which gives you 8. Do 136 divided by 8, and that gives you 17 once again. Then you're going to do 5 cubed to give you 125, and you're going to do 17 times 125 to give you 2,125 units cubed. Just another recap once again. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and then with cosecant it's the opposite of sine, with secant it's the opposite of cosine, and with cotangent it's the opposite of tangent. So adjacent over opposite, hypotenuse over adjacent, hypotenuse over opposite. And then for this example, we're finding all 6 trig ratios. We're going to look at sine 60, and then we're going to see that that's going to be opposite over hypotenuse, 3 over 5. Cosecant is just going to be the opposite. Cosine of 60 is 4 over 5 because it's adjacent over hypotenuse, and then secant is going to just be the opposite, 5 over 4. And then when you're finding the tangent, it's going to be opposite over adjacent, and then when it's the opposite of these, it's going to be the reciprocal flipped, and it's going to be 4 over 3. When we're solving for the 6 trig ratios on a coordinate plane, you're going to do basically the same type of thing that we just did, except you need to find it by using a coordinate plane when it gives you the points. So it gave us the point of -3 and -4. So you're going to put that in on a graph. You're going to find out, and then you need to do the Pythagorean theorem, to find the hypotenuse. So in this case, we figured out that the hypotenuse would be 5. And so when we plugged that in, finding sine of theta is going to be opposite, which is -4, over 5, because that's the hypotenuse. Cosine is going to be adjacent over hypotenuse, which is -3 over 5. Tangent is going to be -4 over 3, because it is opposite over adjacent. And we know that this is going to turn into 3 or 4 over 3 because they're both negatives. And then for cosecant, it's the opposite of sine. For secant, it's the opposite of cosine. And cotangent is the opposite of tangent. Now here's some you-tries. We're going to give you a few examples to do on your own, and you're going to try to figure them out one by one. So I would, after you see all 3 examples on the 3 different slides, you should pause the video. So here's the first example, figuring out, like we looked at later, if the shape will be similar or not. So you may want to pause the video right now to see that. Here's number 2, and it's going to be trying to figure out what this side is using cosine, sine, and tangent. So I would pause it right now to see what's going on. And then for number 3, you're going to be using the coordinate points, like we just did in the last one together, and figure out what the trig ratios are going to be for each one of the 6 trig ratios. So I would pause the video right now to do this problem. Like I said, I'd pause the video because the answers are coming up. These are the answers for the 3 examples we just gave you. So, after seeing this video, I hope that you have understood more about Unit 7 and what we have been learning in that. I hope you do well in the exam.